Hi, I'm Professor Melko, Chemistry PhD, and today we're going to do some practice problems about matter, elements, physical, chemical changes, and conservation of mass. So let's jump into the practice problems. First one we're going to do here is just classifying matter. Okay, in previous videos I've discussed the different classifications, elements, compounds, and mixtures. How would you classify salt water from the ocean? In these practice problems, I encourage you to pause the video, try to answer yourself before we go through and discuss the problem. So feel free to try this problem now. Salt water is a mixture of salt and water, just like it sounds, of course. It is not an element, right? Water itself is not an element. Water itself is a compound, so it's definitely not element. But this water, which is a compound, has another compound, salt, within it. So it's a mixture of two things. It's not an alloy. That is a mixture of metals. So it's some type of mixture. Homogeneous or heterogeneous. Okay, homogeneous or homogeneous means it's uniform throughout. Heterogeneous means it's kind of clumpy, and some handfuls of salt water might not be the same as the next handfuls of salt water. More or less, salt water from the ocean is a homogeneous mixture. Okay, because basically every handful is the same. A heterogeneous mixture would be something like a chocolate chip cookie, where some bites have a bunch of chocolate chips, other bites don't have any chocolate chips. Okay, so that's this one. On to the next problem. We're now going to go through element symbols and names. So in my class, you have to memorize a bunch of the elements and their corresponding symbols, so let's practice some of those now. Again, feel free to pause the video and try to answer all of these yourselves from memory, or consult the periodic table if that helps. First, what element has the abbreviation Ca? This one's pretty straightforward. The element itself starts with those two letters. It's not carbon, but it's calcium, right? The stuff our bones are made from. Mn could be a couple different ones. We have magnesium, we have manganese, okay? We have molybdenum. Turns out Mn here is manganese. Sometimes students find flashcards help in memorizing these harder connections. Write the symbol for the following elements. So here the question is asked in reverse. If I give you the element cadmium, right? It's not calcium, it's not Ca. Cadmium is Cd. Radon and radium are often confused, so make sure you get these distinct. Radon is Rn, whereas radium is Ra. Okay, I know they sound alike. Radon is a noble gas, that's Rn. Radium, Ra. Lastly, the symbol for silver. And this one's a little confusing. It comes from, I believe, a Latin name for silver. The symbol here is not Si, that's silicon. The symbol here is Ag. So that's some exercises, element symbols, and names. Next practice problem, physical and chemical changes. Right? What kind of change is associated with an open beaker of ethanol evaporating? Take a second and try to reason this out yourself. Physical changes are something that doesn't change the elemental composition of the substance. Okay, so if ethanol is evaporating, that's really just, this evaporation is a phase change. Right? It's just changing from liquid to gas. That's all evaporation is. It's still all ethanol. The same molecules of ethanol in the liquid phase are just now entering the gas phase. So all phase changes like this, phase is physical, so this is a physical change. Chemical changes, you're going to want to look for words like flammability, reactivity, burning, something like that, that signifies a combustion reaction, that signifies some chemistry is happening. There might be gas being evolved, there might be a permanent color change, there might be heat released, and that signifies that the atoms are getting rearranged and new compounds are being formed, undergoing some chemical change. Up next, we've talked about in previous lectures how the periodic table is divided into metals, nonmetals, and semimetals. And we need to be able to classify anything looking at the periodic table and identifying metals, semimetals, and nonmetals. What is boron? So this kind of relies on our ability to first identify the symbol of boron, B, And boron lives in this special staircase of semimetals. Okay, so boron here is a semimetal that is also sometimes referred to as a metalloid. So those two names are sometimes used interchangeably. Last one we're going to discuss on this quick practice problem video is a conservation of mass problem. Okay, this is a law, a natural law of nature, that mass is not created nor destroyed. There's also a conservation of energy that says the same thing. Energy is not created nor destroyed. You can convert energy from one type to another, and you can convert from one substance to another in chemistry, but the mass does not change. So if we have 0.750 grams of mercury oxide, okay, and it's decomposing, it's falling apart to make mercury and oxygen. And we know the starting amount of mercury oxide, 0.750 grams, and it's going to form 0.695 grams of liquid mercury. What is the mass of oxygen gas that it is also forming? So we know that this mercury plus oxygen gas, okay, must add up to this 0.750 grams. In other words, we can find the mass of oxygen gas by taking our original 0.75 grams of mercury oxide and subtracting the 695 grams, accounting for the liquid mercury. What we'll be left with here is the amount of oxygen gas here, 0.055 grams. Okay, worry about significant figures here. Remember, go back and watch our lecture on significant figures. For addition and subtraction, okay, the rule is you go out to the least number of decimal places and the things you're adding or subtracting together. Multiplication and division is just about counting the sig figs. For addition subtraction like this, we go out to the least number of decimal places. There's 3 decimal places in the first number, 3 decimal places in the second, so we have to go out to 3 decimal places, and that's why our answer here is to exactly these 3 decimal places, 0.055 grams. So that's all the practice problems I wanted to do today. For more practice problems, you can subscribe to my channel on YouTube for more videos, or check out my weekly office hours on Twitch, where I discuss the latest science news and just go through lecture problems like this and review sessions. See you next time.